I'm going to give you an example using just familiar numbers to help you understand why we can use elimination to solve these systems of linear equations. So imagine I have this equation that 2 plus 3 equals 5. And then let's say I have another equation that 1 plus 5 equals 6. So I've got these two equations. Now obviously we're not solving for anything, there's no variable, but I'm using this to sort of make this point and help you understand this idea. So in my first equation, and let me put my brackets there just so we remember we're looking at this as a set. So in my first equation I can see this 2 plus 3 and this 5 are equivalent. And we know that's true. We're familiar with our arithmetic, our basic facts, so it's easy to look at that and say, yes, I know 2 plus 3 equals 5. And then we have this second equation here, 1 plus 5 equals 6. So we know those two things are equivalent. I could replace 1 plus 5 with 6, or I could replace this 6 with 1 plus 5. Now, when we solve systems of linear equations with elimination, what we like to do is we add 1/2 of each of the equations together to eliminate a variable, and we add the other half of the equations together as well. The point of this is to eliminate one of the variables. But again, showing you this so you understand this concept. If I said I was going to add 5 and 6, so 5 plus 6, since 6 and 1 plus 5 are equivalent, that would be the same as saying 5 plus 1 plus 5. Those would be equivalent. So on the other hand, when I say 2 plus 3, if I were to add 6 to that, here's my 2 plus 3 and here's my 6, that would be the same as I said 2 plus 3 plus 1 plus 5. I'm keeping it balanced because 1 and 5 is equivalent to 6. So I could add 6 to the 5, and it would be the same as if I added 1 plus 5 to 2 plus 3. And we know that because 6 plus 5 is 11, and 2 plus 3 plus 1 plus 5 is also 11. So this is the reasoning behind why this works, why we can just add these equations together and we can still end up with something that is equivalent. I can still end up with that. So I can still say, if I added these together, 2 plus 3 plus 1 plus 5 equals 5 plus 6. That is still true. All right, so let's apply this to an actual system of equations with variables we're going to try to solve for. And let's do, I think I should have enough room here, 4x plus 10 equals 4y, 8 minus x equals 2y. So the first thing we should notice is that not everything is lined up. I do have my y values lined up, but my x variable here is lined up with the numerical value. In order to make this work, I need to make sure everything is lined up. You could technically do it mentally once you're comfortable with it, but to make sure our signs match, to make sure we make no small errors, we want to get in a habit of rewriting. So you could choose to rewrite either of these. You're going to use your commutative property to rearrange these. So I could say that this one here, it's a positive 10, and that's a positive 4. 10 plus 4x equals 4y. I could rearrange that. Or I could rearrange this one here. That minus sign, we would match it with the variable it's next to, so that's actually a negative x. And then that's positive 8 equals 4y. Then you're going to choose whichever one you're most comfortable with, whichever one you want to move. I like to not move or not rearrange the equations with the negatives or more negatives, just because I find that you're more likely to make that mistake of missing one or rewriting one. So I'm going to rewrite it with this top one rearranged. So my system of equations is 10 plus 4x equals 4y. And I'm going to keep this one here, 8 minus x equals 2y. So I don't actually have anything new. It's the same system of equations. I have simply rearranged them. Now you can solve this in two different ways, and I'm going to show you that, but we're going to solve for x and we're going to solve for y. So you would notice I don't have any coefficients that are exactly the same. Here I've got 4 and 2. Here I've got 4 and negative 1. But I do have to be able to change one of the equations to make sure that they have a matching coefficient, or at least that the numerical value is matching even if the signs don't match. So first I'm going to look here. I'm going to say, okay, I've got these y's. I've got 4 and 2, and I'm going to solve that half on this side here. All right, so I'm going to notice, all right, I wanted to turn this 2 into a 4. Well, 2 times 2 is 4, so I know I've got to multiply both sides by 2. So I'm multiplying 8 minus x by 2. Make sure we distribute that to everything in here. 2 times 8 is 16. 2 times negative x is negative 2x. 2 times 2y is 4y. And then I have my original equation here, which was 10 plus 4x equals 4y. Notice I rearranged the order when I rewrote it down here. It technically doesn't matter which order they're in as long as throughout the rest of the problem you keep them in that same order, just to make sure that you don't maybe subtract in one direction with one part and then subtract in the other direction for the other half of the equation. All right, so the first part we know is that, let me choose a different color just to help show this next part. I'm going to put this line here to make sure we have that barrier between the two halves of the equation. 4 and 4, I know if I subtract, that will give me 0, and that's what I'm looking for. So 4y minus 4y. Then I have to do the same thing over here. So 16 minus 10 is 6. Negative 2 minus 4 is negative 6x. If you had done that in the other direction, if you had done something like where you had to do 4 minus negative 2, remember, I'll just put this up here, 4 minus negative 2, we want to be super careful. That would have turned into a positive here. That would have been a plus. All right, so I want to get that x isolated, which means I need to get this 6 off of that side of the equation, leaving me with negative 6x equals negative 6. Need to isolate that variable by dividing by the coefficient. That'll cancel out, giving me 1x equals negative 6. Oop, made a mistake, didn't I? Negative 6 divided by negative 6 is just 1. So x equals 1. So I have solved for part of my system of equations. I found what x equals by eliminating y. Now let's go ahead and do the other part. We're going to solve for the y variable by eliminating x. So what we would notice is that if we want to eliminate x, I need to have the same coefficient. The signs can be different, but the number needs to be the same, meaning that this needs to be 4. Well, this one's easy. If this is 1x here, I'm going to multiply it by 4 to get 4. So I'm actually going to use the same equation. I'm going to modify the same one, but this time I'm going to multiply it by 4 to get what I want. So 4 times 8 is 32. 4 times negative x is negative 4x. And don't know why I did double equal sign there. Don't think didn't make a mistake, right? 8 minus x, 2y, multiplied by 4, multiplied by 4. There we go. All right, so that's going to equal 4 times 2 is 8y. So that is my new equation. And remember, the way we got this is we distributed to all terms in that expression. I'm going to rewrite the other part of the system of equations down here, carefully checking to make sure it matches what we had. This was our original. We just reorganized it to 10 plus 4x equals 4y. Good. There we go. And we're going to solve it the same exact way. Well, almost the same exact way. The difference here is that I have negative 4 and positive 4, which means I'm going to add them together in order for them to cancel out. So I'm going to add all parts together. So 32 plus 10 is 42. Negative 4 and positive 4 cancel out, so I end up with 0 x's. And that is going to equal 12y. So what we're going to do next is we want to isolate that y. So I'm going to divide by the coefficient, because 12 divided by 12 is 1, leaving me with 1y. Whatever I do to one side to keep things balanced, I will do over here. And 12, 12, and 12 is 36. That's 3 times. And then we've got 6 left over, so that will give us 3.5. So I've eliminated the x to figure out what y equals. And now I have my whole solution to this, which is that y solution gives me that x is 1 and y is 3.5. And that is how I solved this particular system of equations using elimination.